Hey everyone, and welcome back to the shop. What we have here is one of my favorite machines in the shop. This is my Baileigh PH28 power hammer. I've had this machine for several years and I absolutely love it. I realize there isn't any really good instructional videos online for how to maintain this machine, how to set it up, all of its adjustments, and how to operate it. So that's what we're going to do today. I'll show you just how user-friendly this machine is, whether you're a huge shop or a small shop. A machine like this will take your work to the next level. So this is the PH28. The PH stands for power hammer, 28 stands for the opening of the depth of this throat. So this machine is strictly a power hammer, unlike the MH19, which is a multi-hammer with a 19-inch throat. The MH19 does two different modes, rigid mode, kind of like a Pullmax, and then a power hammer mode. You remove the pin, it puts the spring into action, and it acts as a power hammer. The PH28 is strictly a power hammer. You cannot lock this in rigid mode. It is a power hammer, spring throw at all times. So the operating mechanism on this is a newer version of basically the original Pettingill or Yoder style, only it is facing front to back. That has some mechanical advantage compared to the original hammer. Let me explain. So an original power hammer has a leaf spring, a set of spools with strapping. The plunger goes up and down in a dovetail, and the crankshaft and motor are spinning this direction while the hammer is going up and down this way. Great design, it's worked for over 100 years. You really can't get much better than that. Let's talk a little bit about the properties of this versus that. So this design, naturally, mechanically, the way this is spinning and the way this is going up and down, it puts a little bit of head shake into the frame of the machine. Not a big issue, especially when you have a cast iron column, support beams, support rods, things like that to keep this thing rigid. And let me tell you, this sucker does not move. But this design does have some engineering advantages. This motor spinning this way as opposed to this way, and this arm going up and down this way in the direction, it takes all the shake and head movement out of the machine. This type of engineering allows a fabricated plate steel construction to have all the rigidity it needs, takes all the side-to-side head shake out of the machine, and makes these thumbnail dies run perfectly true, and that is very, very important. This new style of engineering has become a lot more mainstream. There's lots of different versions and lots of different ideas out there. Another version of this is the Pullmax, built by Stan Fulton. If you're not familiar with that hammer, make sure you check it out. So normally there's some safety covers on the top of this that also keeps the dirt and grime out of the mechanics of the machine. But I have those off because we're going to talk about maintenance. You'll see here I have a note, 13 grease points. I left myself a note because some of them are very difficult to find, and it's real easy to forget one and then make a habit of forgetting that one. The next thing you know, you're wearing the machine out. So I wrote down 13. Let's see if we can find them. All right, well, let's start with some easy ones. On the hand crank here, there's a bearing block. There is number 1. On the spools, we've got 2, 3, 4, 5, 6, 7, 8, 9, 10. Back on the motor side, 11. Now here's one of the tricky ones. See this rear pin? There's a grease fitting on the back of this. Let's go down inside, turn the light on the camera, and if you look up, right there, 12. And we're back on top of the machine here. I just showed you where the one was in the back of this. There's one on the front one as well. 13. Now while we're up here, we will take note. See there's a gap here? That is correct. No, these bolts are not walking out. This pin, as that spring collapses, these do this. There should be a gap there, and this is safety wired. So do not think, oh, that's backing off. I need to clip this and walk it in and tighten it up. You will choke the action of this working. This is set. Do not touch that. So that's all 13 grease fittings that I know of. There could be more, but that's all I've ever been able to find. So I made a note, there's 13. Hopefully there's not 14. If you're aware of any beyond that 13, leave a comment below. Now there is a chance that this electric motor might have one in the nose of that motor. There are none on the exposed portion, and there's a big metal shield around it that we could take off. There might be a grease fitting on this motor, might not. I've never had this cover off, so I couldn't answer that question. If anybody knows, add a comment. Now let's talk about the oiler. It's got a valve on it. It's not like a dripper, so you just open it, let a little oil go in, and shut it off. It oils this ram and the bushing block that's inside this machine block here. Every time you use it, give it a little shot. If you're running it for a while, give it another shot, and then just refill this as required. It's not like a dripper where you would just turn it on and let it have a constant drip. On this machine, give it a nice shot, run the hammer, let it oil that block up. And if you're running it a whole bunch, oil it again. I would say if you're running parts all day, you should give this thing a shot like every half hour. Just give it a little shot. And this whole thing should last you like an entire 8 hours of work. So it's not like you're refilling this thing all the time, because let's face it, you're not running your power hammer all day, every day. So you might use it for an entire day or an entire week, and then you don't use it for a couple weeks. So just fill this up as required. Again, just open the valve, give it a little shot, close the valve. Every half hour or so, depending on how hard you're running it, give it a little bit more oil. If you're running a machine like this, I mean, you're mechanically minded. You know when parts need to be lubricated. More oil is better than anything, so just give it a little bit of oil throughout your day. So you might be thinking, well, how often do you hit these grease fittings? Again, that depends on how much you use your hammer. If you're running a lot of parts and you're using this thing 8 hours a day, 7 days a week, which let's face it, no one's doing that. But you might be building a whole body and you might be using it a lot for a couple of months, and then you're not using it for a couple of months, and then you're just using it like once a week or a couple times a week to make little patch panels, things like that, and then all of a sudden you're using it every day for months again. If you're using it a lot, I would grease it once a week or every other week, if you're using it really, really heavy. If you're just making little panels and it'll run for 5 hours a week, and then there's a couple weeks you don't use it, and then there might be a week where you use it like 2 days constantly, 8 hours, maybe even a third day, 8 hours. Maybe grease it before you know you're going to do that big job, or when you're done that big job, that way it's ready for the next time if you hadn't greased it recently. So it's really up to user discretion. When I'm using it a lot, I'll grease it before a big job, and if that job is ongoing, I might do it every week to every other week. Just one little pump. You don't need to be pushing grease out of everything, but you want to make sure that this thing is greased up. There's a lot of moving parts, and as we all know, the better you take care of things, they will last forever. So the covers that are on here, I'm not going to lie to you. Since I do grease this thing fairly often, these covers are never on, ever. I just leave them off. I'm not going to take them off constantly to maintain this thing. Obviously, you don't want to get your fingers in here when things are operating. That would be pretty stupid. You will not get that finger back. Now, when you're not using the machine, you don't want all the shop grinder dust and things like that getting onto the mechanics of the machine, especially because there is grease on there and all that stuff will stick to that grease. So when you're not using it, just throw like a small sheet or a cover over this to keep the shop dust off of it when you're not using it. Pull that off, make your parts, At the end of the day, when you're all done, just throw that cover back on. It'll really help the longevity of all those moving parts. All right, so let's get into some of the adjustments. There aren't many. Up top here, you can adjust the stroke. You'll see I have 14mm written on there. I wrote that on in the early days, so I'd always remember what size Allen key I needed to loosen that up. I don't adjust that very often, but that is basically where you adjust how hard this hammer hits. The longer the stroke, the higher the hammerhead picks up before it throws down. So if it picks up higher, it's going to generate more inertia and speed on the way down. It's going to hit a lot harder. If it's only lifting up a little tiny bit, just fluttering, it's not going to be hitting very hard. It doesn't have enough time to come up and gain that inertia and momentum to come flying back down. It's just fluttering like the wings of like a hummingbird or something. So up here, you loosen this, loosen that nut, and you slide this anywhere on here you want. All the way this way is the shortest stroke, which is marked on there as 1/4 inch. So the die is only going to go up 1/4 inch before coming back down. The heaviest hit is marked as 3/4 of an inch of stroke. So this will come up 3/4 of an inch before it comes back down. That doesn't seem like a whole lot of adjustment, but let me tell you, that is a huge, huge difference. The light stroke, the 1/4 inch stroke, is a very soft planishing hit. You can do some shaping, it's still very powerful, but you're not going to be crushing stuff. When you put it on 3/4 of a hit, 3/4 inch, that thing is pounding some metal. I almost never have it turned up that high. The setting you see it at is pretty much where I always keep it. I think that's a really good setting for using thumbnail dies on 19 gauge steel, using contact dies to stretch and do like door skins and low crown panels, things like that. If I was shrinking aluminum and I wanted to leave no marks, I might turn that down just a little tiny bit. Or if I'm trying to planish an aluminum panel, I will turn it way down. But for the most part, you can really control that with your foot pedal and get a nice finish. But if you wanted to really finesse it, you could adjust it right there. I'd play with it a little bit, see what you like. But that setting where I have it, it's kind of like a good for all things type of setting, and I leave it there most of the time. This lever right here is an awesome feature. So the dies in this machine are pinned in place. Okay, so you pull the pin, the die comes right out of here. So you might be thinking, well, geez, how do I get that out of there? What do I have to do? Wind this thing all the way down to get enough clearance to get that out of there? Because if I turn the hand crank and lift that up to top dead center, there's still not enough room to get these dies out of here. Well, no, you do not need to wind this all the way down to get your dies out of there. That's the beauty of Chris Rush's engineering mind. Right here, pull that down. Look at how much room we have here now. You can pull these dies out of there. Boom. These are such a tight fit that even just a little oil on there makes them slide in real slow. So you get your die switched out, pull this up, lock that back in. You are back to your setting. So that is a quick release. That is for die changes only. Do not ever operate this machine with this lever released down when this die is in the raised position. If you have that there, that raised up, and you operate this machine, you could bind up the machine and cause severe catastrophic damage to this machine. It even says it right there. Pay attention to your warning signs. So you pull it down, you lock it in, you change your dies out, put that back up, run it. This is a very good positive lock. This will not come out of here during operation, so you do not need to worry about that. Just make sure it is in the detents, or notches. I guess they're not technically detents. That's important, but it almost goes in by itself. You'd have to pretty much try to screw that up to not get it right. So if you watch, when you release this down and raise this up, the entire mechanical head slides up on these blocks, which are machined into the frame of the machine. The whole thing lifts up on that cam, change your dies, lock it in, you're ready to roll. Now let's show off a little bit of the mechanics of this machine. So right here, this spins on an eccentric. That is the backside of the crankshaft, which is timing belt driven off of the motor. This is a hand crank, so you can manually spin the machine, and you only need to do that for setting up die clearance, and we'll get into that here in a second. But I'll give it a little bit of throttle. You'll see how this spins on an eccentric. There is a connecting rod that pushes up and down right there, and that pivots. That rod pivots, making the head go up and down. So you can see how adjusting that back and forth, you will change the action of the machine. You may have just thought to yourself, well geez, he was just running that hammer, but the dies weren't touching. I didn't hear the dies making contact. You're absolutely correct. They were not. When I was just running this hammer at slow speed, you may have noticed there was like 1/4 of an inch to maybe a little less, like 3/16 of an inch of gap between these dies when the hammer came down the bottom dead center. Well, you might think to yourself, well, how can you have 3/16 to 1/4 inch gap and you're shaping 19 gauge or 062 aluminum? It'll never touch the material. So how does the hammer work? And that's the beauty of a power hammer. So it's very, very important that you do not make contact with your panel when the machine is in a binding situation. You do not want this to come down and squeeze the material using the mechanics of the machine in a binding situation where it's coming down and crushing. It's not a stamping press or a rigid hit machine. The power hammer, what you need to do is run an RPM high enough, fast enough, that the mass and the momentum of the mechanics of the machine, as it gets thrown down to bottom dead center, there's enough inertia from the weight of this machine getting thrown down that it goes beyond bottom dead center, takes the spring into action, and actually throws the die down while compressing the spring, and basically bounces off the material and recoils the spring and goes back up. Now, setting that machine up to do that correctly is a very important part, and we're going to get into that, because if you have too much die gap, you can basically get valve float, or you can float the spring. Kind of like over revving your engine, you can get the valves to float where the valve springs just cannot keep up with the RPM. You can get a similar situation in a power hammer. So you don't want too big of a gap here, because at a high RPM you might float the spring. If you have too little of a gap, you're actually putting the machine in a bind, and then the spring isn't doing any work. The actual moving parts, the pins, the bushings, all that is taking on that load. You do not want that to happen. So let me show you how to set this up properly. So there's only a couple adjustments on this machine. You've got 2 locking Allen heads here and an Allen head here. Again, when I was early in on this machine, I made myself some notes, 10mm and 8mm. These are 8s, that is the 10. I have dedicated T-handles that I keep with the machine at all times, one of each. They're always here, so I just pick them up and grab them. To adjust your die gap, depending on what you're doing, you want that 3/16 to 1/4 inch gap. That is at bottom dead center. So grab your hand wheel, and as you turn this wheel, you are manually moving the crankshaft. Bring your dies down to bottom dead center. If you're not familiar with what bottom dead center means, that's when it hits the very bottom, and no matter what direction you turn this, it is picking it back up. So if you come down, right at that spot where it stops moving down and it's getting ready to go back up, that most bottom location is bottom dead center. Bring it down to bottom dead center, and then you want to set this clearance right here. Anytime you're going to do that, anytime you're going to put your fingers in there or do anything, make sure the machine is turned off, because there's the foot pedal right there, and it's real easy to be working here with your hands and accidentally step on that. And let me tell you, if you put your finger in there and that machine runs, you're not getting that finger back. It is going forever. So 3/16 to 1/4 inch gap at bottom dead center. To adjust that, loosen, loosen, loosen. When you turn this, you will move this ram up and down. It's a pretty fine adjustment, and once you get it set where you want it, lock that, lock it, lock it. So I'll do a quick overview on that, and I'll show you just how fast you can adjust your die height. Alright, so I've always got the 2 Allen wrenches. They're always laying right here on the ground in a box. I also always have my dies here in the rack. Let's say we're going to change our dies from one die to the other. Let's pretend I want to take these out and put different dies in, but I'm just going to put these ones back in. I'm going to go over here. I'm going to lift the die up. I'll take this pin out. Take the bottom die out. The bottom die I want. I'm going to put that in there. Put the pin in. Top die out, new top die in, good. Drop it in. Dies are changed. Now we need to set our die gap. We're going to manually turn the hand crank, bottom dead center. 2 Allen wrenches, 8 mil, loosen, loosen, 10 mil. Loosen. Adjust it to where you want it. Usually it's a very fine adjustment. You're just going like a 1/4 turn at most. Let's say that's where I want it right there. I like to put this pretty snug. So let's face it, this thing vibrates. Things can come loose. I've never had it come loose because I always tighten it very tight. Got it where I want it. Locked. Locked, pretty darn tight. We are done. Now there are hex jam nuts on here. I'm gonna be honest with you, I have never in my life ever locked those. I've never had these come loose because I snug them up. If for some reason you wanted to, or you were having an issue with these vibrating loose, then you can lock those jam nuts. They look like they're probably about a 13 mil. Lock it, these can't back off. These two keep this ram, basically lock this from wiggling. This one sets it up and down. With that locked and these locked, I have never had these move, and those thumbnail dies stay oriented absolutely flawlessly throughout an entire job. They never move. It looks very simple, but it is a very well functioning setup, and I love it. These quick pins are also great. There's these clevises. I guess that's what you would refer to it as, the clevis. I have a smaller thumbnail die in the top, so I have a straight through pin on the top. This style pin on the smaller dies, such as this smaller thumbnail die, as that falls on the ground, when this is in here, this could flip down. This can't fit under this die, but when I have the little tiny dies in here, it could actually get underneath of it and hit your material. So, get that back off the ground. I like to run a straight pin on the top. That way it can't accidentally swing down and get under my panel. With the 3-inch dies, it's not a problem because it just physically can't swing past the 3-inch die. There's just no way, so it's not an issue. With the smaller dies, and I have a good bit of the smaller dies, that's why I just run the straight pin on the top. Never had a problem. I always like to run this one on the bottom, and it just makes it quick and easy. So that's how you set your die gap, adjust your height, change your dies, pins, flip it up, drop the pins, new dies in, pin it, release it, drop this back down, fine tune. If you are shrinking a thicker material like 18 gauge steel, you might want to set a little bit more of a die gap. You also might want a little bit more of a throw on the machine. Just gives you a little bit more power when it comes down. If you're doing something softer like aluminum, I do a lot of aluminum work, so I usually set this a little bit on the tighter gap and a little bit shorter of the throw. Gives you a much faster running machine, a little bit of a softer hit. It's a little more easy to control. It's not throwing you around when the panel starts getting some shape in it. But you always want to be somewhere in that 3/16 to 1/4 inch spacing. So here's a very important part about setting up this and saving a lot of time. As you saw, it only takes about 30 seconds to a minute max to do a fulling tool change, even readjusting your die height. But you can eliminate a lot of those problems if you just make sure that all of your tooling is the exact same height. Now, if you're buying your tooling directly from Baileigh, it's not an issue because almost all of their tooling is the same height. Not all of them, but almost all of them. So whether I'm running the little tiny 1.5 inch thumbnail dies, a high crown 6 inch radius, a low crown 24 inch radius, the tool thickness is all exactly the same. If I switch between any of these dies or any of my crown dies, any of my thumbnail shrinking dies, whether it's these little tiny ones or the bigger ones, I do not need to make any die height adjustments. They are all the same. But some of my linear dies are taller. The only time I really adjust my machine is when I throw a linear die in. I've got a handful of different linear dies that I've custom ground. So if I switch to a linear die, I need to change my setup. All my other tooling is exactly the same. So if all my tooling is the same, I almost never have to adjust this unless I'm trying to fine tune the hit. If I want a very soft planishing hit, I can adjust this up and down to get a little bit less clearance, which means I don't have to adjust the big cam at the top to change my throw. I can just adjust my bottom die up and down to get a little bit tighter clearance, which will give me a little bit of a softer hit. You can really fine tune your hit just by moving this up and down a little tiny bit. The slightest bit makes a pretty big adjustment. Like I said earlier, the setting I have up here is a pretty basic, general purpose, all around good setting. I almost never ever change that. Most of my hit adjustments are going to be down here, and it's a very, very fine setting. You don't have to mess with it much, but since I do change into linear dies often, and then back to thumbnail dies or a contact stretching die, I do get into this adjustment quite a bit, changing especially into those linear dies. But you saw how quick and easy it was. It's really, really user-friendly. You can make a 100% change every single setting in 1 minute, 2 minutes if you're going to go up here. Add maybe another minute if you're going to go up there and adjust the actual throw of the machine. But you need 3 Allen wrenches total for every adjustment on this machine. You don't need any other special tools, just those 3 Allen wrenches. So let's talk a little bit about the power requirements. And that is one reason this machine is very user-friendly. This sucker is 220 single phase. So it is friendly to home shops, big shops, small shops. That is sweet because a lot of the bigger machines require 3-phase. Not only does single phase make this a great option for small shops, but so is the footprint. The footprint of this machine occupies a 4-foot by 4-foot square, and it's all vertical. I forget exactly how tall this thing is, but I think it's pretty darn close to like 8 foot. But the footprint, square footage of what it takes up in the shop is a 4-foot by 4-foot space. Obviously you need some working area to stand in front of the machine here and use it. Give yourself another probably 4 foot in front of it. But that is sweet, because you get an old machine like this, and this takes up an entire bay in my shop. From one side of my platform to the other side, I believe this takes up about 22 feet. That is some serious real estate. That's an entire operating bay in the shop where we could have another vehicle. So something like this is not for the small shop. But this machine and that machine, for the most part, can build all the exact same parts. This obviously has a much bigger throat, much heavier rotating mass, so it really moves metal a little bit faster. The other benefit to a big machine like this is it is extremely quiet. You've got almost 10,000 pounds of iron absorbing all that energy that's not being input into the material. It really absorbs the sound. The smaller frame of a machine like this hits extremely hard, shapes just as well, but it is much louder. There isn't mass here absorbing that noise, all that hit. So it really is important that you wear hearing protection when you're running either of these machines, old style, new style. But this machine is significantly louder. I even did a decibel reading on both of these machines at one point, and the pettingill running all out, heavy stroke, hard hit, pedal running to the floor, this was 100 decibels, which is loud. Don't get me wrong, that is loud. Now here's the crazy thing. This machine was 106. So you're probably laughing right now. Yeah, 106, 100, 106. Let me tell you something. 6 more decibels is insanely louder. I mean, painful. This machine here, don't crucify me over it. I run this all the time with no earplugs. I know, that's a terrible idea. But seriously, I run this all out on a piece of aluminum, and it's just this quiet thud sound. It's really not that loud. This machine, painful, painful. That extra 6 decibels is very painful. It doesn't sound like a lot, but 106 hurts. So I literally have a box of throwaways at the base of the hammer at all times. I burn through these things like crazy. Now, I am not a doctor, so do not take my advice on how much hearing protection you should use, but this is all I wear, and I think it does the job quite well. Okay, so let's get into actually a little bit of operating this machine. We went through maintaining it, how to set it up, how to make your adjustments, how to change your dies, how to change your throw, blah, blah, blah. Power requirements, footprint requirements. Let's turn this thing on and actually show you how to use it. So you got your main power. Then you got your on-off switch here, and basically a max RPM dial. Kind of like a TIG welder. Wherever you set this, when the pedal is all out, that is around about the RPM you are running. So if you turn this down to 100 and you hold the pedal to the floor, you will not exceed 100. If you put it at 1,000 and you hit that to the floor, you're running 1,000. If you hit it halfway, you're running 500. It is a rheostat pedal, so you're anywhere in between, but wherever this is set, that is your maximum when the pedal is to the floor. So power on. I almost always have this around the 1200 RPM range. That is about what you want a power hammer to run at. Somewhere between the 1000 to 1200. 1100 is about the sweet spot. I believe the pettingill runs just over 1100. If you exceed the 1200, especially if you go up here to the 1500, and especially if you have your die gap set too wide, you will float the spring. You will overrun the spring and you'll get a spring float. Realistically, you never want to run faster than that. It's not needed. So if you're at 1200 or between 1000 and 1200 and you're getting any sort of float in the spring, you're getting this to flutter, you're overrunning it, that is a basically indicator your gap here is too wide. So you need to tighten that up. Let's pull this pedal out where I can access it. We have our machine turned on and we are at 1200. So if I run this slow, you'll notice the dies do not touch. We are not running enough RPM to get this mass to generate enough inertia to throw below bottom dead center and get that spring to come into action. But if I start picking up a little speed, you'll hear it start to come in. So I slowly ramped up to the full 1200 RPM. So let's dial this down to like 500 and hit the pedal to the floor. At 500, pedal to the floor, with that die gap, we never generate enough inertia to throw that weight down to touch. While it's running, I'm going to start dialing this up and see at what RPM these start to even touch. You can hear the springs starting to act, but it's not throwing it down low enough. We're at 800. It is throwing the spring. We're not making contact yet. So it came in around 900 to 1000 is when it started generating enough throw, spinning fast enough to get that throwing down to make these dies hit with the setting we have at this gap. If we tighten that up, it would have came in a little bit earlier. It also would have been hitting a little bit softer. So again, 1200 is really the sweet spot. You really don't ever want to take it below that. And there's no reason to run higher than that. It's unnecessary. Do all your throttle right here. So just like a TIG welder, you can control your RPM with the pedal at all times. So again, like a TIG welder, this is your maximum. You set your TIG welder to your maximum amps. You set this to your maximum RPM. 1200 is the sweet spot. Let's see if we can get this thing to float. Right there. You heard it overrun and then they stopped hitting because it fluttered. I had this sucker cranked at 1500. Let's see if we run it at 1300 all out. It ran 1300, 1400. It overran it. So really 1300 is your max when you have about a 1/4 inch gap. Again, if that was a little tighter, we could get away with a little more. Totally unnecessary to run above 1200 RPM. I keep it there all the time. Well, that's about going to wrap it up for this instructional video on how to maintain, set up, and operate a Baileigh PH28 power hammer. We're not going to get into how to make panels with it in this video, but we will have an ongoing video series that's making non-stop videos on how to build panels with a power hammer, as well as an English wheel and all types of metal shaping. So make sure you subscribe to the channel and stay tuned for all those videos. This is a brand new channel. It just came out. I'll be filming lots and lots of content non-stop throughout my workday and posting it as often as I can. So there's going to be lots of power hammer shaping videos coming up. I'll teach you all about how to shrink, how to stretch, how to make all different shapes, all different situations, all different materials, everything we do in and out on a daily basis in my shop, Phillips Hot Rods. So make sure you subscribe to the channel. I hope you like this video. Give it a thumbs up, subscribe, turn on that notifications bell, and I'll catch you on the next one.